Hey guys, it's Axiomatic Uncertainty here, and today I'm going to be doing a simple proof, and this is essentially a proof based upon circles, and this is just a proof of a theorem. So let me just draw this out here. It's a rough line, but essentially, actually here, I think this will work. Just grab this. There we go. Okay, so we have this. Here, this is the radius that extends to the point P on this circle, and let me just draw this. Okay. So essentially, this is perpendicular, and that's what we're proving. That the tangent line to a circle with any with center O at any point on said circle is the perpendicular to radius OP. So this would be radius OP. And this would be line L. This is the tangent line. The proof is that this is perpendicular to this radius. And so how are we going to do this? Well, first thing we need to know is that the radius, we can find an equation here if we know the point P and we assume that this is the center, the origin. And how we're going to do this is the equation for a circle, which would be x squared plus, sorry about that, y squared equals 1. Okay, so we have this. If the radius changes, it'll be linear. I can prove that later as well, just to show you. But for now, we're just going to be solving for this. So first thing we need to know is that with this equation, if we have a p's y value and x value, we can find the slope of this and then find the slope of a perpendicular line to this, which would be the opposite of the reciprocal. So I'll just show you how to do that. So first we're going to take y squared, right, equals 1 minus x squared. Okay, sorry. So essentially, all we've done is subtract this over. So let's just draw a line to here. And this is going to be essentially the equation put into y squared equals form. And then we're going to take the square root of this on both sides. So y equals plus or minus square root of 1 minus x squared. Okay, and this ends up being the equation here. So now what we need to do is we need to take p, and we're going to essentially assume, so let's just get this, assume p has coordinates x comma y. Okay, so essentially we are assuming that p has the corresponding coordinates. So if we plug in an x value here, we get a y value here, and that's the value at p. So this essentially is an equation for the y value at the x value of p. So here, what we can do to find this slope is we can take the y value p and the x value p and divide them. So we have the y value first, plus or minus square root of 1 minus x squared, right? That's going to be it. And then all of this over x. And this would be the line here. So this would be that. That is what this is. So this line gives us the slope of this. And in order to get that other equation, which would be the equation for this tangent line, we need to find another value, which would be right here. We're going to want our, I was just caught in a thought. We're going to want our reciprocal, the opposite of the reciprocal. Since this is a plus or minus, we could switch it to a minus or plus. That's essentially what you'd be doing. But that's still plus or minus, right? So it doesn't really matter. So let's just draw that in. Plus or minus x divided by square root of 1 minus x squared. Okay. That is the equation of the perpendicular. Now, in order to prove that this is the tangent line to the circle, or the equation for it, that is, for its slope, what we need to do is we just need to take the next bit, which is the derivative. So we have x squared plus y squared equals 1. We want to do implicit differentiation. Okay? And so what we're going to do to get this is we're just going to go dx of x squared plus y squared. Now, we could use explicit differentiation, but this is much easier because obviously this is much messier. Or this is much messier to take the derivative of. So we're going to go with this. Now, here, we're going to want to go 2x. Okay. So that's the derivative of x squared. Plus, now, the derivative of y squared. Which here, let's just choose a color. This is going to look nice. 2y, right? Times. Just draw this out. dy over dy by dx, right? So, that way, now, if we set this equal to the derivative, let's get our other color, derivative of 1, which is equal to simply 0, okay? And that means that now all we have to do is we just subtract over the 2x, so let's write this out first. 2y dy over dx. There we go. Equals, so equals negative 2x. Okay, and now all we need to do is divide by this. So we're going to divide by this in order to isolate our dy dx. And once we've done that, we'll get dy, right? Dy by dx equals, and then these two will just cancel, and we'll be left with negative x over y. And now, as a last little bit of simplification in order to finish off the proof, what we need to do is we need to take this y and we need to substitute in this here, because that is equal to y, and that's in terms of x. And so we're going to say dy by dx equals negative x over y. So let's write out the y first. And y is plus or minus the square root, and we can bring the plus or minus up to the top. So I'll just write it like this. 1 minus x squared. Okay, let's just redraw a little bit of that. That looks really bad. And it's hard to tell, then if it's x times 2 or x squared. So we got a plus or minus up here. So let's just draw that out. Plus or minus x. And now we've done that, we just need to do one more thing, which is just circle and circle. And as you can see, these two are equal, right? Equal. And that is the entire proof. So essentially, we've taken 1 over, or the perpendicular to the radius that extends to that point, and we've taken the derivative, and they have the same slopes, and because they originate from the, or because they both intersect the same point, that means they are the same line. So I hope you enjoyed this video. Please remember to leave a like and subscribe if you enjoyed it. Comment down below if you have any ideas for future videos or anything you'd like to see from me in terms of math that you'd either like help with or just are interested in. Thanks, and peace out.